Hello Year 12 and welcome to our next video here. We're looking at graphs and equations generally, and specifically today we want to look at dilations, where we stretch a graph horizontally or vertically. Now to stretch it horizontally by a factor of a, we replace a with x over a. To stretch the graph vertically by a factor of a, we'll replace y with y over a. Let's jump straight into an example here. It's all a fairly short exercise. So, I have this relation. It's not a function, but a relation. X over 3 minus 12 all squared plus y over 2 plus 8 all squared equals 16. Now, in its undilated form, we would have a circle here with a centre at 12, negative 8 and a radius of 4. I'm just going to quickly sketch that. Here's my circle. Now, 12, negative 8, oops, I'm going to do this again. 12, negative 8 and a radius of 4 means that it doesn't have any intercepts at all. And I suppose that makes life a little difficult in some respects. That's what my x-axis looks like. My y-axis, my centre here is at 12, negative 8. Righto. Now, when I dilate this, I'm dilating it horizontally by a factor of 3 and vertically by a factor of 2. That's going to move my centre. Right, I'm going to triple the x-coordinate to bring it to 36 and triple my y-coordinate to bring it to negative 16. Right, I'm tripling the x and doubling the y. Now the radius no longer becomes regular, okay, because of this dilation. So I'm still going to have a shape here, but it's stretched further sideways than vertically, so I'm going to have an ellipse that doesn't look too much like that. Let's try again. Let's try a nicer ellipse. Don't know if that's nicer, but nonetheless. Right, if it didn't have any intercepts before, it's not going to have any intercepts now. All we're doing is multiplying any of the x-coordinates by 3, any of the y-coordinates by 2. Still my x-axis, still my y-axis. Just going to write down here. This is x minus 12 squared plus y plus 8 squared equals 16. Now in this case here, my centre now becomes, remember we triple the x, so 36 and negative 16. I could put a couple of other points on here perhaps. Now really, that's all the critical points there, but let's just mark the sort of 12, 3, 6 and 9 o'clock positions. Right, the maximum that this relation reaches is 4 units above that, so that point there is at 12, negative 4. The furthest to the right it reaches is going to be 16, negative 8. The minimum that this relation is going to reach will be 12, negative 12, and the furthest it reaches to the left will be 8, negative 8. Okay, that's where my circle sat on the number plane. Now this one here, let's mark the corresponding points here. We don't normally have to do this, but because we don't have any intercepts, it's probably at least good for this instructional exercise here. So, I'm just going to triple my x-coordinates. So 3 lots of 16 is 48. Now, 3 lots of, I double the y-coordinate, so that's negative 16. And over here, instead of being at 8, negative 8, 3 times 8 is 24, and 2 lots of negative 8 is negative 16. So that's that point there. This high point here, instead of 12, I'm going to have 36. Instead of negative 4, I'm going to have negative 8. And my minimum here, 36, and the negative 12, I will double that to get negative 24. Okay, that's dilations. Now, if I had something like 2x minus 12 all squared, Well, that would be perhaps like dividing x by a half. Okay, so that would have a dilation factor of 1/2. Rightio, in which case I halve all of the x coordinates, and so on. Righto, that's it for dilations. If you've got any questions, make sure you ask me. I'll see you in class. Thanks, guys.